Section 3.1, Implicit Differentiation. All right, so let me explain what we're going to be doing in this section. All right, we might have an equation that looks something like this, and it's either difficult to solve for y or impossible to solve for y. So we're going to see how do we take the derivative of this equation, or an equation like it, without having to solve for y first. All right, that's what we're going to look at here, implicit differentiation. All right. Let's look at this equation. Y is equal to x cubed plus 4x. All right. So what if I were to ask you, what is y to the fifth? Wouldn't that be like raising both sides of this to the fifth? So that'd be x cubed plus 4x to the fifth like that. Now what if I were to tell you, let's take the derivative with respect to x of this right side right here of x cubed plus 4x to the fifth. Let's take this derivative with respect to x. All right, so how do we do it? Well, in the last section we learned about the chain rule. We had an outside and an inside. Here we have an inside of x cubed plus 4x. My outside is something raised to the fifth. So how do I take the derivative of this? Well, that's going to be the derivative of the outside, so 5 times this stuff to the fourth. At the inside, times the derivative of the what? Inside. X cubed plus 4x, right? And then we would go from there. We take the derivative of that stuff and so forth. But let's look at what we did. We took the derivative of this stuff. So we took the derivative of this side. So what we really did here was we took the derivative of what? Y to the fifth. So we had y to the fifth. Let me write it a little bit over here so I have room to work how I want to. All right, so we had that. So what did we do here? We took the derivative of y to the fifth, right? So we really took the derivative with respect to x of y to the fifth right here. And what did we get right here? We got 5 times, what is this quantity also known as? X cubed plus 4x. X cubed plus 4x is just y. So that's really y to the fourth times d over dx of, what is this part right here? X cubed plus 4x again. That's really y again, right? So what are we saying? We're saying that this derivative, d over dx of y to the fifth is equal to 5y to the fourth times d over dx of y. Or I could say that's equal to 5y to the fourth times dy over dx. Now that's where y is some function of x. All right, not a big deal if you didn't get what we were doing there, because we're going to do some more here. All right, let's suppose that y is just some function of x, okay? Let's suppose y is equal to, I don't know, x squared plus 3x, okay? Now, let me ask you this. What would y cubed be? Y cubed would be what? This stuff cubed. X squared plus 3x cubed, right? Now, what if I would like to take the derivative with respect to x of x squared plus 3x quantity cubed? How would I do that? I would use the chain rule again. So I'd say derivative of the outside gives me 3 times something squared. At the inside times the derivative of the inside. According to the chain rule, I would do that. Well, let's look at this in terms of y, what we just did, okay? Really, this part right here was the derivative with respect to x of what? This stuff, which was what? Y cubed, right? So really I was taking the derivative with respect to x of y cubed at this step. Well, what did we say that was equal to? We said it was 3 times this stuff squared times d over dx of this stuff right here. So what is this part right here? That part's also known as what? Y, right? So that part gets a y. What is this part as well? That part is also y. So what do I get here? I get 3y squared times dy over dx. All right, now, let's look at this part, and let's look at the one we did just before this one, okay? Let me grab my paperwork so I can see what the expression was that we had before this. Before this, we had something like the derivative with respect to x of y to the fifth, right? And what did we say that was? We said that was 5y to the fourth times dy over dx. So let's put this all together here, okay? Let's say y is some function of x. So what do I do if y is some function of x? When I take the derivative with respect to x of it, I put that 5 times the front, reduce that power by 1, times the derivative of the inside part, dy over dx. Look at this one, it follows the same pattern. I'm taking the derivative of y cubed with respect to x. So I'm going to say 3 times y to the second, 3 times y to the second, times dy over dx. So if we're following that same pattern there, let's suppose y is a function of x, but this time I have the derivative with respect to x of y to the seventh. How do I take the derivative of that? If y is a function of x and I'm taking a derivative with respect to x, that's going to be 7 times the front times y to the sixth times dy over dx. How about the derivative with respect to x of y to the, I don't know, maybe 3/2? How would I do this one if y is a function of x? I would say what? 3/2 times y to the 3/2 minus 1 times dy over dx. Now that's going to be your basis right there for implicit differentiation. All right, so maybe we'll look at some more examples now, okay? We kind of already started looking at some examples. Let's suppose we're told to find dy over dx by implicit differentiation, okay? Like the notes that you have. So we're going to start with those first examples on the notes. In part A, we're going to have x squared plus y squared is equal to 100. Now, I want to use implicit differentiation here. I do not want to solve for y. How am I going to handle this? Well, we're looking for dy over dx. So what I'm going to do is I'm going to take the derivative with respect to x of both sides of this thing, or I could think of taking a derivative with respect to x of this term, and this term. So derivative with respect to x of x squared plus the derivative with respect to x of y squared is equal to the derivative with respect to x of 100. Now notice, this x matches up with that x, so I take the derivative just the old way that we're used to, 2x to the first, plus. Now what about this, the derivative with respect to x of y squared? Remember how this variable is different than this one, right? So we're going to have to use implicit differentiation here. So we're going to say that's what? 2 times y to the first times dy over dx. It's equal to, what's the derivative of a constant? 0. Now, what did our directions say? They said to find dy over dx, right? So what I'm going to do is I'm going to solve for dy over dx right here. I'm going to isolate it. So solve it just like you would an equation now. Subtract 2x from both sides. So 2y times dy over dx is equal to negative 2x. Divide by 2y on both sides. So dy over dx is equal to negative 2x over 2y. Or I could simplify this to dy over dx is equal to negative x over y. So there we go. We found dy over dx. All right, let's look at part B. I'm going to need to erase this for part B. So I'm going to need some room for B. B has the same direction, so find dy over dx by implicit. Part B, we're going to have x cubed times y plus 4x y cubed minus x is equal to 7. All right, so let's go ahead and take the derivative of this term, this term, this term, and this term, okay? So I'm going to take the derivative with respect to x of x cubed y plus the derivative with respect to x of 4xy cubed minus the derivative with respect to x of x is equal to the derivative with respect to x of 7. All right, taking the derivative of each term here. Right here, I'm going to have to use a product rule. How do I use a product rule? I'll say first, which is x cubed, times the derivative of the second, times the derivative of the second, plus the second, which is y, times the derivative with respect to x of the first, which is x cubed. So all the stuff here is this part right here. I still need plus this part next. Now there's a couple of different ways I could do this one. I'm just going to look at it like 4x is the first part, and y cubed is the second part. So 4x times y cubed, I use a product rule again. I say first, which is 4x, times the derivative of the second. The second is y cubed, plus the second, which is y cubed again, times the derivative of the first, times the derivative of 4x. This part right here is the same as that part expanded. Now we're right here, minus. What's the derivative with respect to x of x? Just 1 is equal to derivative of 7 is 0. Over here we have x cubed. This I can write as dy over dx. Plus, bring down your y. What's the derivative of x cubed with respect to x? 3x squared. Plus 4x times, what's the derivative of y cubed with respect to x now? These variables differ, right? So I'm going to have to say 3y squared times dy over dx. Plus y cubed comes down times what? 4 minus 1 is equal to 0. Now the directions here were to find dy over dx. So I need to isolate these dy over dx terms and solve for them. So let's see, I'm going to say this is x cubed times dy over dx. This part I'm going to say is 3x squared y. Plus, this part I'm going to say is 12xy squared times dy over dx. Plus, this part I'm going to say is 4y cubed, and then minus 1 is equal to 0. Now, what are we trying to get by itself? The dy over dx. So let's get these terms here and here all by themselves on the left-hand side of this equal sign. And we'll bring this, this, and this over to the other side. Just algebra at this point. So we have x cubed times dy over dx. Now let me put this term next. So plus 12xy squared dy over dx is equal to, if I bring the 1 over, I'm adding 1 to both sides, right? If I bring the 4y cubed over, I have minus 4y cubed. And if I bring the 3x squared y over, I have minus 3x squared y. Now keep in mind what I'm solving for. Dy over dx. So let's factor it out of these two terms right here. Dy over dx. If I factor it out of here, what am I left with? X cubed plus 12xy squared. And then the other side is 1 minus 4y cubed minus 3x squared y. Now how do I finally solve for this part right here? I divide both sides by this x cubed plus 12xy squared. So I'm going to divide this side and divide that side. So what does that give me? That gives me dy over dx is all by itself on the left-hand side is equal to 1 minus 4y cubed minus 3x squared y, all divided by this stuff right here, x cubed plus 12xy squared. There we go. We found dy over dx again. Let's see, what else do we have? Let me see. We have part C. Part C. Part C wants us to do the same thing. Find dy over dx. Part C, find dy over dx. And part C, we're going to have the sine of x squared, y squared is equal to x. Let's find dy over dx by using implicit differentiation. So what happens if I take the derivative with respect to x of both sides? What do you notice here? You have an outside function and you have an inside function. So you're going to have to use the chain rule. What's the chain rule again? Derivative of the outside. What's the derivative of sine? Cosine. At the inside, so bring down this inside right here. X squared, y squared, times the derivative of the inside, times the derivative of x squared, y squared, is equal to, what's the derivative of x with respect to x? Just 1. All right, so cosine of x squared, y squared comes down, right? Times. What about taking a derivative of this? That's a product, so I'm going to have to use the product rule. So to use the product rule, say first times the derivative of the second plus the second times the derivative of the first, close off my parentheses, is all equal to 1. So over here I have cosine of x squared, y squared. Over here I have x squared times, what's the derivative with respect to x of y squared? 2y times dy over dx, right? Plus y squared comes down times 2x is equal to 1. All right, so what are the directions? Find dy over dx, right? So I'm going to need to solve for this part right here. Well, I could distribute in cosine in here, multiplying it through, but that'll give me more work to do. What if I go ahead and divide both sides by this cosine of x squared, y squared? Then what am I going to get here? I'm going to get 2x squared y times dy over dx plus 2xy squared is equal to, and if we divide both sides by the cosine here, we're going to have 1 over cosine of x squared y squared. Well, I still need to solve for dy over dx, so I'm going to subtract this part from both sides. So I'll get 2x squared y times dy over dx is equal to 1 over cosine of x squared y squared minus 2x y squared, right? Now, to finish solving for dy over dx, I'm going to have to divide both sides by 2x squared y. But if I divide this by 2x squared y, it's going to give me a nasty fraction here, right? So what I could do to avoid that is I could say, okay, what's 1 over cosine? Which identity is that? Secant? So in other words, I can replace this with the secant of x squared y squared. Let's do so. So let's bring down 2x squared y. Let's bring down the dy over dx from right here is equal to, but this part we're going to call what? The secant of x squared y squared minus 2x y squared. All right, let's go ahead and solve for this dy over dx. So we're going to divide both sides by 2x squared y. So we'll have dy over dx. dy over dx is equal to the secant of x squared y squared minus 2x y squared all over 2x squared y. There we go.